Hello, in this video, we will be solving the systems of equations with three equations, three unknowns, using the elimination slash addition method. So as we see, we have a problem, and the problem is a three system or three equation with three unknowns being x, y, and z. Sometimes when you're solving these systems, the unknowns will be denoted as x of 1, x of 2, and x of 3. But in this case, our unknowns is x, y, and z. So first thing we want to do is that we want to try to eliminate the variables. And as we eliminate the variables, or as we eliminate the variables with the coefficients, we're able to have simplify our system to a point where we'll come up with some solution for x, some solution for y, and some solution for z. So the first thing we want to do is that we want to multiply -2 to equation 1 and add it to equation 2 to get equation 3. And I will show you that right now. So as we see, we want to multiply -2 to equation 1. Hold on one sec. All right, let's try again. -2 times 2x plus y minus 3z is equal to -2 times -4. So as we distribute, we get -4x minus 2y plus 6z is equal to 8. Now, we're going to add this to equation 2, which we see as 4x minus 2y plus z is equal to 9. So we'll add these together, and as you see here, the x's or the x terms will eliminate, will go away. However, -4y plus 7z is equal to 17. So here we have equation 1 being multiplied by -2, and then we add equation 1 that's multiplied by -2 to equation 2 to get our equation 3. So this is our equation number 3 right here. Now the next thing that we'll do, well, let's do this. Let me just write down what I did first. How about that? So we multiplied we multiplied -2 to equation 1, and we added add the expression to equation 2 to get equation 3. So here is what we did right here so far to get this. Okay, make a note of that. And now we will switch boards. So we'll clear this. So, as you see, now we're going to multiply -3 to equation 1. Let's just write that out so that you can see. Multiply -3 to equation 1 and multiply 2 to equation 3, right? And add the equations together. Okay, everybody see that? So let's do that right now. So we have -3 times 2x plus y minus 3z is equal to -3 times -4. Then we have 2 times 3x plus 5y minus 2z, which equals to 2 times 5. Now, we're going to perform the distributive property over addition and some of it over subtraction and get our simplified expressions, and then, of course, do any other further simplification where necessary. So this will become, after distributing, -6x minus 3y plus 9z is equal to 12. And then this is 6x plus 10y minus 4z is equal to 10. Now, what do? We simply add these two equations together, and here we have 7y plus 5z is equal to 22. This will be our equation number 4. Equation 4. That's our equation. That's not multiplying, and I'm a little bit worried about that. Let me go ahead and take that one off. This is actually equation. Let's put equation 4. I know I got parentheses around the others, but I think I could decipher what I meant by equation 1 and then just multiplying values. So this is equation 4. Okay, right here. Equation number 4. Everybody see that? You can take time to pause the video and copy any necessary notes from this screen, and we will continue with the problem. So we'll change boards. I'll cover all bases. I want to make sure that that's equation 4. Okay, so now continuing on, we want to multiply we want to multiply 7 to equation 3 right? And then we want to multiply 4 to equation 4. Add them together. Add the equations. Add the equations together. Get equation 5. Sorry there. Had some background uh, issues back there. Sorry, everyone. But y'all didn't hear because I don't have the whole audio on. So how are we doing? So now, to show you how to do this, let's show you how to do this. So this will be 7 times negative 4y plus 7z is equal to 7 times 17. You see this? Then we have 4 times 7y plus 5z is equal to 7 times 22, I believe. Was that 4? 7? Yeah, 7 times 22. That's right. No? Sorry, 4 times. There we go. 4. 4 times 22. Okay, 4 times 22. Okay, so now when we distribute these numbers to each of the terms and each of the equations, we get negative 28y plus 49z is equal to 119. And then we have 28y plus 20z is equal to 88. Okay, so now this becomes what? So after we multiply uh, all and these numbers to the two equations and then distribute and also add both of the uh, new equations together, we get equation 5. Equation 5 is going to be 69. 69z is equal to 207. Okay, so that's our equation 5. This is equation number 5 right here. This is equation 5. This is our equation 5. How do you see that? Okay, take the time, pause the video, copy down these notes if you can, and we'll continue with this problem. And it's a little bit tedious, but once you get the hang of this and experience with solving these equations and breaking these things down to where if you get one variable, you actually can start to substitute uh, those values in to the smaller equations, uh, and then of course you'll get other variables, and then once you get the two variables that you need, then you can plug those two variables into any three of the original equations to solve for that one more variable that you need, and we'll show you this. And this is basically a form of row operation, but the row operations, and we'll get into that when we get into matrices, is where the system is. the system or each of the equations is representing a row. Um, but here is the row of terms, right, in this particular situation. So now I'll go ahead and switch boards, clear it. Okay, so we'll start again, continuing on. So our fifth equation was 69z is equal to 207. And so now we solve for z. And as we solve for z, z is going to equal to 3. So now we can perform back substitution, right? We perform back substitution. We can now perform back substitution. And like I said, folks, in my other videos, my handwriting is much neater than this when we're in the classroom and on the whiteboard. But practicing with the stylus pen, it takes some time to get used to because you got to stay within the guides of the bamboo on the bamboo tablet. And sometimes if you go outside the dots or that area, then the pen will start jumping all over the picture. The image starts jumping all over the place. And yeah, so just bear with me. Still learning this. Getting the hang of it though. So we can now perform back substitution. So when we do that, we substitute what? We substitute z is equal to 3 back into either equation, either equation 3 or 4. To what? To solve for y. So we're going to just use equation 4. How's that? That's okay, right? You use the equation that has, less complications there. So now we have 7y plus 5 times 3 is equal to 22. And then we have 7y, and that's going to be plus 15 is equal to 22. We solve or take negative 15 to both sides, which is allowing us to solve for y here in this case. And this will become 7. So as we divide 7 to both sides, what do we get? Y is going to equal to 1. We see that. So we're almost done, ladies and gentlemen. We're almost done with this. So we're going to perform back substitution now because we have the two variables that we need, which is y and z. So now we just perform back substitution in either one of the three original equations to solve for x, and then we're done. We'll have our solutions to this problem. So take the time, pause the video, jot down the notes, and we're going to clear the board and continue on. Now, let's do what? Now, as we said, use back substitution. back substitution. To substitute y is equal to what? 1. Z is equal to what? 3 into equations into either of the original equations. Okay? So here we have, we'll substitute this back into equation number 1. Is that right? Equation number 1. Yes. So we'll say 2x plus, now this is y is equal to 1, minus 3, and z is 3, negative 3, times 3, negative 3 times 3, which is equal to negative 4. Okay, so this will be 2x plus 1 minus 9 equals negative 4. So 2x minus 8 is equal to negative 4. So now we add 8 here to both sides. And 2x is equal to 4, dividing 2 to both sides. And so x is going to equal to 2. So we have our solution, and our solution is x is equal to 2, y is equal to 1, and z is equal to 3. And it'll look like this. This is our final answer. Now let me show everybody out there and all over the world. I mean, you can actually learn how, after you've gotten your solution, you can plug it back into the original system to see if it's correct. And let's hope that that is true. That is. So let's do that. So we'll clear this board here. And let's look at this. So let's run a check. Always good to run a check. Check yourself. Check your work. So the original equation we had, okay, our solution was 2, 1, and 3. So watch this. So we have 2 times 2 plus 1 minus 3 times 3. Now, let's see. Now, we know that the original equation, its solution was negative 4. So let's see if we get the same thing. 2 plus 1 minus 9. So that's going to be, whoops, 2 times 2 is 4. Sorry, folks. Whoa, I know I was getting a little nervous there. I said, uh-oh, we done made a mistake somewhere. So this is going to be 5 minus 9, which is going to equal to what? negative 4. So remember, let me just write this off to the side that this is our original equation. Our original system was this, as you see, right? So we got negative 4 for this. So we're correct. So let me just write down the second equation. We're running the check here. Okay. So as we see, look at this right here. As you see this answer here, what we got here matches the answer to the original equation that we were solving for. So let's do the second one. The second equation: 4 times x is 2 minus 2 times y, which is 1, minus uh, z, minus z, which in this case would be 3. What would that equal? So this will be 8 minus 2 minus 3. So this will be 6. Okay, let's make sure we ain't make no crazy mistakes here now. 4 times 2 is 8, negative 2 times 1. This is going to be negative. Okay, yeah, 2 times 1 is 2. And then plus, that's supposed to be a plus z. Okay, plus z, which is a plus 3. Sorry about that, folks. Making sure. All right, now, okay, I'm not getting nervous again. Okay, we got 9. So this matches the original equation as well, as you see, the original equation solution. So now the last one, and make sure when you're doing these problems, folks, that you might the solution that you found for X, Y, and Z. Make sure that you check all three. If you got 2 equations, 2 unknowns, 3 equations, 4 equations. Makes it depending upon how many equations you got. Make sure you check your solutions for all the equations because sometimes it might work for some, and then people are like, oh, it's gonna work. It's gonna work for the rest. No, okay. Experience was I had a student one time that thought that they were correct because they used an answer. Their answer was different from mine, and what happened was the answer that they've chosen worked for one of the equations, but my answer worked for all 3 of the equations. And of course, we finally came to an agreement with that. So make sure that you test the solution in all of your equations. Okay, this is 3 times 2 plus 5 times 1 minus 2 times 3. Okay, so this will be 6 plus 5 minus 6. So this will be 11 minus 6, which is equal to 5. So thank God that this all came out the same. Everything came out fine.